All right, this time we are going to look at investment whereby someone puts in money into an account, then later on you withdraw. All right, for example, you may be given that Johnny invested 230,000 into an account paying 15% per annum compounded monthly, and after 2 years he deposits 100,000 into the same account. And then after 3 years, he withdraws 86,000. Determine the amount of money which will be in the account (11 years after the first deposit). Okay, then we need a timeline. Let me just read this. Johnny invested 230,000 into an account, paying 15% per annum, compounded monthly, and after 2 years, he deposited 100,000 into the same account. Then after 3 years, he withdraws 86,000. Determine the amount of money which will be in the account 11 years after the first deposit. All right, first of all, you need to draw a timeline. So this is the timeline. All right, this is T0. All right, this is T0. That's when he made his first initial deposit, which is 230,000. Then 230,000. Then they say after 2 years he deposited another one. So this is 1 year, this is 2 years. So this is T2. He deposited 100,000 into the same account. And then after 3 years, he withdraws 86,000. So here, this is 1, T2, T3, T4, T5. So T5 here, he withdraws 86,000. So 86,000 is going out of the account. 100,000 is getting in because it's a deposit. 86 is getting out. Then they say that determine the amount of money which will be in the account 11 years after the first deposit. So 11 years, which means this is T0, then we need T11 here. How much will be in the same account? It's very easy. You're just gonna say 23,000. So it's gonna be A is equal to 230,000, which you must grow You must grow this 230,000 to the end, isn't it? So how do you grow it? It is 1 plus 0.15. It is compounded monthly to the power of 11 times 12, because it is compounded monthly. Then when another deposit is made, you are supposed to say plus, because this amount is going into the account. So you grow this, so plus 1 plus 0.15 over 12. But for how long? From T2 to T11, which means it's 9 years. So it's 9 times 12. Okay, because it's compounded monthly. So it's divided by 12 times 9 times 12. Then when someone withdraws, when Johnny withdraws, it means you're supposed to subtract 86,000. But when you subtract that 86,000, you must grow it. Because if it was in the account, it was going to grow in the account. So you must subtract it, but subtract it and then grow it. Because that amount is no longer going to grow in the account. So we need to subtract the amount of money that was going to grow in the account. So plus 1 plus 0.15 over 12 to the power of T5 to T11. So it's 6. So it's 6 times 2. Then you use a calculator. Just punch this once into a calculator, then you get the answer. 23, 230,000, 1, 2, 3. 1 plus over 12 to the power of 11 times 12 plus 100,000. 1 plus over 12, 9 times 12 minus 86, 1, 2, 3, 1 plus 0, divided by 12 to the power of 6 times 12. All right, then the amount of money will be $1,000,000 So we are going to have 1,357,598 rands and 49 cents. This is the amount that will be in the account at the end of 11 years. So let me just explain. First of all, every deposit you must grow it. Then every deposit that goes into the account, you grow it. Like 230, you grow it. This is how you grow it. This is another deposit, you grow it. But the withdrawal, you are supposed to subtract it, but you must grow it as well. Subtract, then grow it. Then this is the amount at the end. Now I need to talk about the future value annuity. Okay, future value annuity. All right, I'm just going to give you a scenario. Maybe, for example, someone wants to buy a house in 10 years' time. So he decided to pay the house in 10 years' time, to pay it cash. So he started investing. Maybe per month he said, I'm going to have monthly installments of 5,000 every month. He opens up an account whereby he is paying 5,000 every month. Then by the end of 10,000, he is going to withdraw a large sum of money. So we call that large sum of money, we call it the future value. So in other words, future value, you are going to have big amount of money later we're going to have big amount of money later. We call it the future value. And the future value is given by this formula. F is equal to X in big brackets 1 plus I to the power of n minus 1 over I. That's the future value. So in other words, the future value, it involves someone depositing on regular basis, maybe on monthly basis, on quarterly basis, or on yearly basis. That's what we call the future value. And at the end of a period, that person is going to get large sums of money, or is going to get big amount of money. And that big amount of money, we call it the future value. So for the future value, it's big amount of money later. It is big amount of money later. That's why we call it future value. Big amount of money later on. And then it's given by this formula, whereby F, it is the big amount of money later. Okay. Then X, those are the deposits, the regular deposits, and they're equal. Okay, maybe this deposit, you pay them, they might be monthly, they might be quarterly, or they might be yearly. So these ones, you pay them regularly. Okay, then I, of course, I is the interest. And then, yeah, that's all. And then N, it is the period with which the person is going to be depositing an equal amount of money regularly, maybe on monthly basis. So that N is the period. Okay, for example, Paul decided to buy a house in 10 years' time. So you deposit, he decided to open an account which he deposits $5,000 every month. The account pays 13% per annum, compounded monthly. Then the question is that determine the amount of money which will be in the account after 10 years. Okay, so in other words, we are going to have, Paul is going to have a large sum of money after 10 years. Paul decided to buy a house in 10 years' time. He decided to open an account which he deposits $5,000 every month. The account pays 13% per annum, compounded monthly. Determine the amount of money which will be in the account after 10 years. Okay. So in other words, Paul is depositing every month. He's depositing 5,000 every month. So this 5,000, we call it X. That's X. Let me just use another white marker so that you understand. So in other words, this 5,000, can you see this 5,000? We call it X from this formula. And then our interest, this is our interest, which is I. And then we have 10 years, which is N. Okay, so now we can calculate the future value. And we know that future value, F, we are looking for future value. And then do we have X? Our X is 5,000. And then do we have I? Our I is 0,13. Then do we have N? Our N is 10 years. Okay, then we can calculate the future value. F is equal to big bracket 1. Oh, it's X, then big bracket 1 plus I to the power of N minus 1 over I. Then our future value. Then our X there, it is 5,000. Big bracket 1 plus I, which is 0,13 over 12. Because it's compounded monthly, then it's 12 times 10. Then minus 1 over 0,13 over 12. Then from then, you're just gonna say 5,000, 1, 2, 3, 5,000. And then you're gonna say 1 plus 0,13 over 12 to the power of 12 times 10 minus 1, close brackets. Then we have this 0.13 over 12. So at the end of, so the future value is going to be 1,220,000 and 184.59. So this will be the amount of money in the account which Paul opens. All right, on the previous video, I've explained what present value, what future value is. Future value, that's when you are going to have large sums of money in future. Then present value, that's when you've got large sums of money now. That's present, large sums of money now. And then it may be a loan. Then you must repay that loan by means of installments, maybe monthly installments. Every month, maybe you're supposed to pay 300 rands every month. So I'm just going to give you a formula, then I'm going to explain on that formula. All right, present value, annuity. All right, it's given by P is equal to X 1 minus 1 plus I to the power of negative N. You must be careful there is negative N all over I. This formula is given, you can find this on the formula sheet. Where P, that's the large sums of money now. Now, okay, that's the reason why they say present value. Then X, that's the installment, whereby you're paying maybe every month or quarterly or yearly. Then I is the interest rate. It is the interest. Let me just say interest. And then N, it is the period. For example, you want to buy a house, maybe a house costs 800,000, and then you're supposed to repay the house by means of monthly installments, maybe for 8 years. That 8 years, That's the N. Okay, and after this I need to explain what is the difference between number of payments and number of years. Okay, I'll explain it maybe on the next example. All right, this is period. N is the period. It can be in years or something. All right, I'm going to give an example. Let's say Paul decided to buy a car. So he borrowed 180,000, which should be paid. We should be repaid. This is repaid by means of installments, by means of monthly installments. Okay. The loan is charged at 17% per annum, compounded monthly. All right. In this case, you're supposed to determine the amount of one monthly installment. So determine the amount of a monthly installment. Okay, all right. Before you do anything, I'm going to use a red marker here, whereby he borrowed 180,000. So which means 180,000. He's given 180,000 now. Because if you go to a bank, you go and borrow, they will give you the money. Maybe it's after maybe 2 weeks time or one week or 3 days. When they give you that large sums of money, you are given that large sums of money now, and it's present value. It's different from future, because future value you are going to have large sums of money later. Present, you get large sums of money now. That's present value. Okay, so 180 you borrowed from a bank is given now. So he's supposed to repay this by means of installments. Then the loan is charged at 17% per annum. You understand that? The loan is charged 17% per annum. Determine the amount of monthly installment if he should repay. If he should repay in 5 years' time. So 5 years' time now. This 5 years' time, you can see that this 5 years' time, it is the period. So in other words, this is our present value, and then this is our I, and then 5 years' time, it is our N. But what are you looking for? Determine the amount of monthly installment. Monthly installment. So monthly installments, this is an installment which gives us what? X. So this is our X. Okay. First of all, you're supposed to write down the formula, whereby you're going to say P present value, which is the large sums of money now, it is equal to X. X, it is the amount of monthly installment. In this case, it's monthly installment. Sometimes you're supposed to repay it in maybe yearly or quarterly, but in this case, it's monthly. So when it's monthly, we're going to say 1 minus 1 plus I to the power of negative N, all to the power of I. Can you see that? Then, what is our P there? We see that our P is 180. We are supposed to write down 180,000, okay, equals our X. We are looking for X. We are looking for X. How much is he going? How much is the monthly installment? That's what you're looking for. So 1 minus 1 plus I I, it's 17, it's 0.17, compounded monthly, divided by 12 to the power of 12 times, how many years? 5. So this is negative, you must be careful. Then 0.17 over 12, you must be careful, it is with a negative. Because people, they make a mistake whereby they say positive. Positive, that's when it's future value, whereby you say future value f is equal to x, big brackets, 1 plus I to the power of n. There is positive n, it's not negative, then minus 1. Now, with the present value, we've got negative n, okay. Then from this, we are supposed to solve for x. So if you're solving for x, it's very easy, because you're just gonna say, you're just gonna say multiply by 0.17 both sides. Multiply by 0.17 both sides. 0.17 both sides over 12. So that this will cancel out this. So in other words, we are going to say 180,000 multiplied by 0.17 over 12. Then equals x, then this 1 minus 1 plus 0.17 over 12, all to the power of negative 12 times 5. Okay, then we divide by this bracket. You can see if you divide by this bracket both sides, you're going to divide by this bracket both sides. 1 plus 0.17 over 12, of negative 12 times 15. Then we divide by that both sides. 1 minus 1 plus 0.17 over 12 divided by negative 12 times 15. So this will cancel out this. Then we remain with x. Then you are supposed just to punch, as it is, just take your calculator, then you punch these figures into your calculator as they are. So you're gonna say 180,123 multiplied by 0.17 over 12, then 1 minus 1 plus 0.17 divided by 12, then it is to the power of negative 12 times 15. Then that must be your monthly installment. So there the monthly installment is going to give me 2,000. So it's 2,770 rands 21 cents. So that's your monthly installment.